A colossal traveler has just entered our solar system. It is older than the Earth itself. Hurtling through space at a terrifying speed of over 200,000 kilometers per hour. It doesn't belong here. Scientists have named it 3I Atlas, the third interstellar visitor humanity has ever witnessed. But what baffles the entire astronomical community is this: it doesn't shine with the brilliant glow of a familiar comet. Despite being 5 kilometers wide and weighing tens of billions of tons, it appears as just a faint smudge of light, drifting silently through the endless sea of stars like a ghost from the farthest reaches of the cosmos. And on the night of December 19th, 2025, it will make its closest approach to Earth. On that night, will you be able to look up and see it? Or will it simply glide past, leaving no trace for most of humanity? On the night of July 1st, 2025, under the vast, endless skies of the Southern Hemisphere, in a small control room in the middle of the Rio Hurtado Desert, Chile, computers connected to the automated Atlas telescope system were tirelessly scanning the heavens. The work was typically monotonous, searching for moving points of light, determining if any asteroids were on a collision course with Earth. But amidst the steady stream of images, an unusually faint streak of light appeared. It wasn't a satellite, nor was it camera noise. It was moving at a strange velocity. Just hours later, the object was given a temporary designation A11PL3Z. For astronomers, these dry labels are routine, but the accompanying data made them pay attention. Its preliminary orbit wasn't a closed loop. It didn't circle the sun like familiar asteroids. Instead, its path was wide open, stretching into infinity. This was the telltale sign of an interstellar object, a traveler from beyond our solar system. The information spread like an electric current. Within 48 hours, observatories large and small across the globe turned their telescopes to its coordinates. Subsequent observations confirmed it. Its orbit was hyperbolic, with an eccentricity exceeding 6, a value that definitively proved it came from the outside. The official name was announced 3I Atlas, the third interstellar object ever detected by humankind. The 3I placed it in line after Oumuamua 2017 and Borisov 2019, while Atlas honored the system that made the accidental discovery. Because it showed signs of outgassing like a comet, it was also given the designation C2025N1 Atlas. The story grew more interesting when scientists combed through archival data. In test images taken on June 14th by the Zwicky Transient Facility and the Vera C. Rubin Observatory, they found the faint trail of the very same object. These pre-covery images were like finding an old photo in a family album, suddenly revealing a moment you met someone long before you realized their importance. Thanks to this, the trajectory of 3I Atlas was refined with high precision, showing that it came from the direction of the constellation Sagittarius, would cross through our system, and then leave forever. The news quickly escaped the confines of the laboratory. International newspapers ran headlines: "An emissary from the stars approaches Earth." On social media, the name 3I Atlas became a trending topic. People created illustrations of a comet with a long, blue-green tail, imagining a magical performance in the night sky. Short videos went viral. Get your cameras ready. An interstellar comet is coming. But when the detailed figures were released, that excitement quickly deflated into disappointment. The comet would be at its brightest in late October. But at that exact moment, Earth would be on the opposite side of the sun, as if our entire planet had been blocked from its seat in the cosmic theater. And at its closest approach to Earth on December 19th, 2025, it would still be 270 million kilometers away, nearly twice the distance from the Earth to the Sun. At that range, its brightness would only reach a magnitude of 11/1200ths of times fainter than the limit of the naked eye. No one would be able to see it with their eyes, not even with consumer-grade binoculars. For the public, it was a letdown, but in the scientific community, the feeling was the exact opposite. They understood that even if it wasn't going to paint brilliant ribbons of light across the sky, 3 Atlas was still a priceless gift. It wasn't a performance, it was an ancient record, a rare opportunity to understand other star systems and how the universe operates far beyond our own backyard. This shift in atmosphere changed the question. It was no longer about will we get to see it, but rather, what is the true nature of Three-Eye Atlas? And what can it reveal about the universe that we never knew before? To better understand Three-Eye Atlas, let's start with a simple analogy. Imagine you throw a ball. If you toss it lightly, it falls back down. If you throw it harder, it might circle around and return, like a satellite orbiting the Earth. But if you throw it with enough force, the ball will fly away forever, escaping your control. Atlas. Is that ball an object on an open trajectory, one that will never return? Measurements show it entered our solar system with a hyperbolic excess velocity of about 57 km, 7 times faster than the fastest spacecraft ever launched by humans. At that speed, it could travel from the Earth to the Moon in just 2 hours. This is irrefutable mathematical proof that it came from somewhere else, beyond the Sun's gravitational dominion. But the most staggering figure is its size. While Oumuamua was only a few hundred meters long and Borisov was less than a kilometer wide, the nucleus of Three-Eye Atlas measures up to 5.6 kilometers across, with a mass of over 33 billion tons. Picture it this way. Oumuamua was like a skyscraper. Borisov was a hill. But Atlas is an entire mountain of floating ice, with that much mass. The jets of gas escaping its surface could do little to alter its course. It plows straight ahead like a massive freight train, indifferent to the cosmic winds. Furthermore, images from the Hubble Space Telescope captured a rare phenomenon, an anti-tail. Normally, a comet's tail always points away from the sun, pushed back by sunlight and solar wind. But Three-Eye Atlas displayed a trail of dust pointing towards the sun. The logical explanation is that the dust particles were too heavy. They weren't light enough to be blown away. So they were simply left behind along its path, creating a reverse trail. It's like the fine exhaust smoke from a convoy of trucks scattering in the wind, while the heavy pebbles kicked up by the tires fall straight back down to the road. Digging deeper. Spectroscopic analysis from the James Webb Space Telescope. JWST unveiled another secret. In the coma of Three-Eye Atlas, alongside the familiar water and carbon monoxide, scientists detected an unusually high ratio of CO2, the highest ever observed in a comet. This was a shock. It suggests that the parent star system where Three-Eye Atlas formed may have had a completely different recipe. The CO2 frost line might have been in a different location, or unique conditions may have prevented water ice from escaping. A study published in the Astrophysical Journal Letters called this the first chemical fingerprint from another star system. In other words, Three-Eye Atlas is like a cosmic time capsule. It preserves the primordial ingredients from the dawn of a distant star system, then travels for millions of years through interstellar space to randomly visit ours. By analyzing it, scientists can compare the building blocks of planets in other systems with what we are familiar with, and from there, test whether our solar system is the norm or just a strange exception. This explains why, despite the public's disappointment over the lack of cosmic fireworks, the scientific community views Three-Eye Atlas as a revolutionary event, not just because it's bigger or stranger, but because it opens a rare window, a chance to touch a piece of the universe out there, right on our own doorstep. And then, a much larger question arose. If a single, accidental visitor is enough to shake our long-held theories, what will happen when we start discovering dozens, or even hundreds, more interstellar guests in the near future? When the first data from Hubble and James Webb confirmed the unique nature of Three-Eye Atlas, many scientists declared it was not just an ordinary astronomical event, but a turning point. If the study of planet formation was previously based only on local data from within our solar system, we now have a physical sample from elsewhere, living proof that every star system can tell its own story. It is this very difference that makes Three-Eye Atlas a natural laboratory. As Dr. Emily Rice from New York commented, the magic here isn't that it's a comet, but that it's a comet from somewhere completely alien. Every speck of dust, every molecule of ice it carries, could have formed billions of years ago under ancient stars that have long since died out. Looking at it is like reading an old page from the universe's diary, a page that no other planet in our system could ever show us. And that very page could answer the questions humanity has always pondered. Is our solar system typical or an outlier? Is life an inevitable outcome or just a random stroke of luck? The impact of this discovery extends beyond the world of research. It has forced space agencies to change their approach. For the first time, a global observation campaign was deployed in just a matter of days, mobilizing everything from space telescopes to orbiters at Mars. It proved that 21st century science is no longer confined to isolated labs, but is a multi-layered, coordinated network, ready to act when the universe grants us a rare opportunity. And from this, the idea of standby mission spacecraft waiting at Lagrange points to intercept such objects is no longer science fiction. Because, as an internal ESA report once stated, understanding interstellar visitors today could determine humanity's potential for extraterrestrial survival tomorrow. We have witnessed milestones that changed how humanity sees the cosmos. Copernicus in the 16th century proved the Earth was not the center. Apollo 11 in 1969 put a human on the moon. The 2019 photo of a black hole turned theory into reality. According to many scientists, 3I Atlas is the next milestone. It may not dazzle us with imagery, but it forces us to rethink Earth's role in a galaxy that is constantly in motion, continuously exchanging material. Professor Monica Grady in the UK even drew an analogy, saying this moment is like the first time we picked up a radio signal from a distant place, not because it carried a message, but because it confirmed we are not alone in the diversity of the universe. Above all, the story of 3 Atlas is a lesson about ourselves. When we choose to follow a faint speck of light millions of kilometers away, record every tiny piece of data, and search for meaning within it, we are proving that curiosity and the desire to connect are inseparable parts of the human spirit. We are small in the cosmos, but it is because of our smallness that we know to look up and ask questions. 3I Atlas will eventually leave, disappearing from view in 2026. But its legacy will remain for the first time. We realize that interstellar travelers are not rare, random events, but maybe a regular part of the bigger picture. And if that's true, humanity is standing on the threshold of an entirely new era, an era where the question is no longer if we will find another interstellar visitor, but rather when the next object like 3I Atlas appears. Will we be content to just watch from afar? Or will we be bold enough to launch a probe to go out and touch it? Could 3I Atlas be just a natural phenomenon? Or could it be evidence of something far greater is there, hidden within its cold, hyperbolic trajectory, a clue about other worlds, perhaps even about life beyond Earth? Or is it all just a random game of cosmic chance, with no deeper meaning other than to remind us that the universe is always in motion? Whatever the answer, 3I Atlas has opened a new door. It shows that travelers like it are not uncommon, and that in just a few years, when the Vera C. Rubin Observatory becomes fully operational, we might witness dozens of similar objects being discovered every year. Perhaps within the next decade, we will move beyond remote observation. A true intercept mission could be launched, directly approaching an interstellar comet and bringing back samples of material from another star system. And who knows? Perhaps one day, from those very samples, we will find the signal of organic molecules. The first hint to the question humanity has always longed to answer, are we alone in this universe? That future is not far away. It will arrive sooner than we think, if we continue to ask questions and pursue things that seem small and faint. And when it does, points of light like 3I Atlas will no longer be just science news. They will become milestones in human history, marking the moment we learn to push the boundaries of who we are. So, what do you think? Is 3I Atlas just a lifeless, wandering chunk of ice? Or is it proof that the vast universe still holds secrets about life? Comment with your thoughts below. Which scenario do you believe in? Don't forget to subscribe so you don't miss the next discoveries from NASA, SpaceX, and the JWST. And if you found this video valuable, please share it so more people can join us on this journey to explore the cosmos.